Hello students, we have understood the angle criteria, that is AAA, criteria of similarity, in our previous video. Now in this video, we will study about SSS, that is side criteria of similarity. Do you know what is this SSS criteria of similarity about? It is nothing but converse of angle criteria. And according to it, if corresponding sides of two triangles are proportional to the sides of other triangle, then their corresponding angles will be equal, and hence the triangles will become similar. First, let us perform an activity and also check whether this is true or not. Let's draw two triangles, say ABC and PQR, in such a way that AB is equal to 8 cm, BC is equal to 12 cm, and AC is equal to 16 cm. And in triangle PQR, PQ is equal to 12 cm, QR is equal to 18 cm, and PR is equal to 24 cm. Now let us take the ratio of the corresponding sides, say AB upon PQ, BC upon QR, and AC upon PR. Keeping the value of each sides from triangles ABC and PQR, we have AB upon PQ as 8 upon 12, BC upon QR as 12 upon 18, and AC upon PR as 16 upon 24. Reducing all these ratios, we get 2 by 3. Therefore, we find that ratio of each corresponding side is equal to 2 by 3. Let us now measure the angles of these two triangles. Do you know how to measure these angles? Yes, using protractor. On doing this, we find that corresponding angles of these triangles are equal. That is, angle A is equal to angle P. Angle B is equal to angle Q. And angle C is equal to angle R. From here, we can conclude that if we take two triangles such that they have corresponding sides proportional, then their corresponding angles will also be equal. So we can say that converse of AAA criteria of similarity is also true. But if we want to write this in the form of theorem and prove it, how can we do it? Absolutely. We call this as side or SSS theorem of similarity, which says if in two triangles, sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal, and hence the two triangles are similar. Now to prove this theorem, let's make two triangles, ABC and PQR. To prove this theorem, we will again use some basic properties that we have studied in our previous classes. To prove this theorem, we will use property of corresponding angles formed by two parallel lines and its transversal. We will also use SAS congruency criteria for two triangles and our BPT, that is basic proportionality theorem. So as per our theorem, let's make two triangles ABC and PQR. Let us write down what we are given and what we have to prove. We are given that in triangle ABC and triangle PQR, the ratio of their corresponding sides is equal. That is, AB upon PQ is equal to BC upon QR is equal to AC upon PR. And we have to prove that angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. That is, triangle ABC is similar to triangle PQR. For that, we have to make some constructions. Accordingly, draw line ST in triangle PQR in such a way that AB is equal to PS and AC is equal to PT. So now we have triangle PST. So let's prove this theorem. We are given that AB upon PQ is equal to AC upon PR. But we have AB is equal to PS and AC equal to PT by construction. So if we replace them in our equation, we get PS upon PQ is equal to PT upon PR. So line ST will be parallel to line QR. But can you answer why? Yes, you are right. By converse of basic proportionality theorem, which states that if line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side of the triangle. Now this is true for section SQ and TR, and also it is true for segments PS and PT. Therefore, the ratio of these segments will also be equal. That is, PS upon SQ will be equal to PT upon TR, or PS upon PQ will be equal to PT upon PR. Thus, by converse of BPT, we have line ST parallel to QR. Since for these two triangles, sides are proportional, since ST is parallel to QR, the corresponding angles formed by transversal PQ will be equal. Now students, for triangle PST and triangle PQR, we can say that angle S is equal to angle Q and angle T is equal to angle R, as they are interior corresponding angles of two parallel lines formed by transversal PQ and PR respectively. And also angle P is equal to angle P because it's a common angle. Hence we can say that triangle PST is similar to triangle PQR by AAA similarity criteria. Accordingly, if in two triangles their corresponding angles are equal, then both the triangles are similar. Therefore, we know that if angles are equal, their sides will be in equal ratio according to the conditions of similarity. Therefore, ratio of PS by PQ will be equal to ratio of PT by PR will be equal to ratio of ST upon QR. This is our equation 2. But students, recall that by our construction, we have PS equal to AB and PT equal to AC. Substituting this in equation 2, we get AB upon PQ is equal to AC upon PR, which is equal to ST upon QR. This is our equation 3. Now students, compare our equation 1 and equation 3. On comparing, we get ST upon QR is equal to BC upon QR. Therefore, ST is equal to BC. Now students, for triangle PST and triangle ABC, we have side PS equal to side AB and side PT equal to side AC by construction, and side ST equal to side BC, which we just proved. So we can say that triangle PST is congruent to triangle ABC. Students, can you think how? Yes, you are right. By applying SSS congruency criteria of two triangles. According to this criteria, if in given two triangles all three sides are equal, then they will be congruent to each other. So here in our case also, all the corresponding sides of both these triangles, that is PST and triangle ABC, are equal. So they are congruent. Now apply CPCT. We get angle A is equal to angle P, angle B is equal to angle S, and angle C is equal to angle T. But students, we have already proved that angle S is equal to angle Q and angle T is equal to angle R, as they are corresponding angles of two parallel lines ST and QR formed by the respective transversals. So replacing these angles in our equation 5, we get angle A is equal to angle P, angle B equal to angle Q, and angle C equal to angle R. Hence we conclude that triangle ABC and triangle PQR are similar by applying AAA similarity criteria. Now students, that we have proved that if we are given for two triangles, the corresponding sides are proportional, we can prove that they will have corresponding angles equal. And thus, both these triangles satisfy our conditions of similarity. So we can say that triangle ABC will be similar to triangle PQR. So students, we have proved both the points. But stop students, and note one very important point. For checking the similarity of polygons, we have to check both the conditions, namely, both the corresponding angles should be equal and the corresponding sides should be proportional. But in case of triangles, we can check only one condition, as if one condition is true, the other condition gets true automatically. So students, what we have learnt in this video is that if for two triangles, their corresponding sides are proportional, their corresponding angles will be equal, and hence both the triangles will become similar. In the next video, we will see another criteria for similarity, that is side angle side, also called as SSS similarity criteria.